Mobile cellular network. The evolution of mobile cellular networks is a journey from simple analog voice calls to a future where artificial intelligence and holographic communication are integrated into the network itself. Each generation typically arrives every 10 years, bringing a massive leap in speed, capacity, and functionality. The evolution timeline: 1G to 6G. 1G, the analog era, 1980s, technology, analog cellular. Capability, voice calls only. Experience, known as the brick phone era. Call quality was poor, battery life was short, and security was non-existent. Calls could be intercepted by radio scanners. Speed, 2.4 kbps. 2G, the digital revolution, 1990s, technology, digital, GSM, CDMA. Capability, voice plus SMS, text messaging. Experience, introduced digital encryption, security, and better voice clarity. Phones became smaller and more affordable. Later versions, 2.5G/GPRS, allowed very basic web browsing. Speed, 64 kbps to 1 Mbps. 3G, the mobile internet age, 2000s, technology, UMTS, HSPA. Capability, voice, text, and mobile data. Experience, this generation enabled the smartphone revolution. For the first time, users could check emails, browse the real web, and use basic apps like GPS and early social media. Speed, 2 Mbps to 21 Mbps. 4G, the era of video and apps, 2010s, technology, LTE, long-term evolution, WiMAX. Capability, high-speed mobile broadband. Experience, designed primarily for data. It made high-definition, HD, video streaming, YouTube/Netflix, Uber-style apps, and online gaming a seamless mobile experience. Speed, 100 Mbps to 1 Gbps. 5G, the Internet of Things, 2020s, technology, 5G NR, new radio, millimeter wave, wave. Capability, ultra-low latency and massive connectivity. Experience, beyond just faster phones, 5G is built for machines. It supports the Internet of Things, IoT, autonomous vehicles, and smart cities by allowing millions of devices to connect simultaneously with almost zero delay. Speed, 1 Gbps to 20 Gbps. 6G, the intelligent future, expected 2030s, status, currently in research and development. Expected features, *terahertz, tHz, frequencies, using even higher bands for extreme speeds. AI native, the network will use AI to optimize itself in real time. Holographic communication, seamless 3D video calls and immersive extended reality, XR. Global coverage, integration with satellite networks to eliminate dead zones in the middle of the ocean or sky. Speed, up to 1 terabit per second, 1000 Gbps. Comparison summary: generation decade primary service key technology 1G 1980s analog voice amps, TAX 2G 1990s digital voice, SMS GSM, CDMA 3G 2000s mobile internet UMTS, CDMA 2000 4G 2010s mobile broadband, video, LTE, WiMAX 5G 2020s IoT, low latency 5G NR, wave 6G 2030s *AI, holographic, sensing tHz, satellite integration. Modulation schemes from 1G to 6G. Modulation is the process of mapping digital data, ones and zeros, onto a physical signal, radio waves. As we move from 1G to 6G, modulation has evolved from simple analog waves to extremely complex multidimensional digital patterns that can pack massive amounts of data into the same amount of spectrum. 1G, the analog era, frequency modulation, scheme, FM, frequency modulation, how it worked: similar to FM radio, 1G networks used frequency division multiple access, FDMA. Your voice was represented by slight variations in the frequency of a continuous radio wave. Efficiency, very low. Each user required a dedicated 30 kHz slice of spectrum just for one voice call. 2G, the digital shift, FSK and GMSK, scheme, GMSK, Gaussian minimum shift keying, how it worked: 2G introduced digital modulation. In GSM networks, GMSK was used to smooth out transitions between frequencies to prevent interference. Key advance, it allowed for multiplexing, TDMA, where multiple users could share the same frequency by taking turns in very fast time slots. 3G, spreading the signal, QPSK, scheme, QPSK, quadrature phase shift keying, how it worked: 3G moved away from changing frequency and instead changed the phase of the wave. QPSK can represent 2 bits per symbol by shifting the wave's timing. Key advance, 3G used CDMA, code division multiple access, which spread a low-power signal across a wide bandwidth using a unique mathematical code for each user. 4G, packing the wave, OFDM and QAM, scheme, OFDM, orthogonal frequency division multiplexing, and 64 QAM. How it worked. 4G doesn't use one big signal, it breaks the data into thousands of tiny, orthogonal subcarriers that don't interfere with each other. Key advance, QAM, quadrature amplitude modulation. By varying both the amplitude, strength, and phase of the wave, 4G could pack 6 bits per symbol, 64 QAM. 5G, extreme density, 256 QAM, scheme, scalable OFDM and 256 QAM. How it worked. 5G uses the same principles as 4G but with higher precision. Key advance, 256 QAM allows for 8 bits per symbol. 12 This requires a very clean signal. If there is too much noise, the phone automatically drops back to a simpler scheme, like 64 QAM, to stay connected. 6G, the future, OTFS and AI native modulation, scheme, OTFS, orthogonal time frequency space. 13 How it works. Traditional OFDM, used in 4G/5G, struggles when you are moving very fast, like on a high-speed train, because of the Doppler effect. Key advance, OTFS modulates data in the delay Doppler domain rather than just time frequency. This makes the signal nearly immune to the distortions caused by high-speed movement. There is also talk of 1024 QAM or even 4096 QAM for stationary ultra-high-speed links. Summary table of modulation evolution. Gen main scheme multi-access data unit 1G FM, analog, FDMA continuous wave 2G GMSK/FSK TDMA/CDMA 1 bit symbol 3G QPSK CDMA 2 bit symbol 4G 64 QAM/OFDM OFDMA 6 bit symbol 5G 256 QAM/OFDM OFDMA 8 bit symbol 6G OTFS/1024 QAM *AI define 10 plus bit symbol